पिंग हो रहा था पीसी
वो कैसे possible है? Our job for today is PC पे firewall लगी होगी. TCP normalization. What does TCP normalization mean? Before we go here into the concept, I'll tell you how it affects and what part of communication does this affect. It affects a lot, but they're not the common ones. Let's have a look at this. I'll create this topology, and between R1 and R2, I'll create neighbor relationship of BGP, a BGP neighbor relationship. Do you think it'll come up? This will be my inside. And this will be my outside. Do you think that the neighbor relationship will come up between R1 and R2?
First class only BGP does not
Huh?
work on PICs.
BGP does not work on PICs? No, between R1 and R2. I don't care about the PICs. Let's configure IP addresses first. 10, 11, 11, 1. No shut. IP route 10, 11, 11. Right? On R2, .20.2. No shut. Default route pointing towards 20.10. Then finally PICs. Check the interfaces. P0 is top. IP address is 10, 11, 11, 10. No shut. Name if inside. Interface Ethernet 1. 20.10. No shut. Name if. Good. I didn't do anything special. I can ping this end. I can ping 20.2. Nothing special. It's just the firewall in the middle. At this time, can R1 telnet into R2? Can. Why? Because it's a TCP connection going out from here. So it should be allowed to go out. Now I need to set up BGP neighbor relationship. For BGP neighbor relationships, you'll have to understand one thing. If you check show IP route, there is a default route, but it does not have a direct route to 192.1.20.2. For BGP neighbor relationship, you should have a direct route
TCP and BGP.
in BGP. Basically, he should know in his routing table where 192.1.20.2 is.
Yes.
On a default route, he will not be able to find out the neighbor relationship. Create a neighbor relationship. Router BGP 100. Neighbor is what? Remote autonomous system number, say 100. See this command, because in his routing table he knows where 192.1.20 is, that is the only reason he can make neighbors. If you don't see, he was able to communicate to 20.2. Before he was able to communicate to 20.2 because of the default route. But remember, for neighbor relationship, he should have the full route in his table. Otherwise, he's not able to send his packet there. Good? From R2, same thing. Check this out, show IP route. Which route do I need to give here?
10.11.
10, 11, 11. 20 dot. Did I give a good route here? Yeah. Okay. Now from here also I'll do what? 100. Neighbor 10, 11, 11, 1. Remote AS is 1. Do you think this will come up? The neighbor will come up. Do you think it'll come up? Yes or no?
Yes.
Why yes?
Because the connection should how many?
They can reach each other, yes, obviously they can, but the thing is, this is outside, this is inside. This is outside, this is inside. Will that cause a problem? No. Why? Why did it not cause a problem? Because this is outside. Right? And firewalls by default inspect only TCP and UDP.
Yes.
How did it work with BGP?
TCP, so BGP also works on TCP.
BGP only works on TCP one, not also, it works on TCP. BGP, the underlying protocol is TCP. It does not have any header of its own. There is no BGP header. It uses TCP to do a lot of its stuff as the underlying protocol. You can even have a look at it. BGP is actually TCP. There is no BGP header separate. It's just TCP port number 179. Okay, so although when you do it on both sides, this guy also tries to initiate connection, this guy also tries to initiate connection, but the connection that was initiated from here will work because it's going from inside to outside, and all the replies to that connection will also work because the connection table, right? So BGP right here, BGP will try to send out some links right here. These are TCP connections, right? Because it's going out, a connection table will be set up right here for the return traffic. So when the same traffic returns, it will be checked against this connection table and let in. So anything that is originated, see, origination depends on the SYN packet, the first packet that comes out from TCP. That is this, from R1 to R2. After that, everything else will be allowed because the first packet goes through all the checks. Every other packet does not go through those checks. Clear? Now that was not the problem I had. The problem that I'll have now is this. Only remember from this information, remember everything in TCP, everything in BGP is stored in the TCP packet. In the TCP packet. In this packet, you have something. See, right now there is no options field. If you look at the packet, TCP header, it has a field called options. Right now there is no options, so the field is missing. Right now there is no options. Those options field are used for special characteristics of certain protocols. Right? Just keep that in mind. Keep that options field in mind. Let's do one thing now. Let me go into R1. I'll enable authentication. Neighbor 192.1.20.2. Password Cisco123. I'll do the same thing on the other side. Router BGP 100. Neighbor 10.11.11.1. Password is Cisco12.
What type of authentication is this?
MD5. Now I'll tell you. The moment you do give this password is not used for encryption. This is used for, if you remember the term, checksum. MD5. What this will do is all the packets now which are leaving R1, all the packets that are leaving R1, right? This password will find a checksum and store that checksum in a field, but he doesn't have a header to store it in. Where is he going to store it in? TCP header. Inside TCP header, there is a field called options. A lot of options. Option number 19 is the one which is used to store this checksum. This value of the checksum. He stores it in the packet. So he stores it in this green packet. Right? This packet moves out, reaches the firewall. Now this is where TCP normalization comes into play. TCP normalization states it's enabled by default on a firewall. It checks each TCP packet that is going out, each and every one which is leaving you. It checks for all the fields, right? Normally the options field are not present. Normal. So that situation is called normal. But here now, he saw that there was something in the options field. So what he'll do is he'll try to normalize the packet. By doing what? By removing this field. By removing this field. Which field? Option number 19. It was put in there by whom? By the BGP process here, to include the checksum. And then he sent out the packet including the checksum. But when it reached the firewall saw option 19. He does not drop the whole packet. He clears that option 19 and lets the packet go out. Lets it come here. R2 needs to verify if this is from the same guy or not. So he needs to see the checksum. But when he checks the options 19 field, there's nothing in there. So he discards the packet. He says, I don't want this packet. I don't know who someone has tampered with this packet. I don't know. I can't find the checksum in there. If you check the message on R2 now, what does it say? No MD5 digest. Digest means checksum. I cannot find the checksum in here. Why? Because he removed it. Who? The firewall. The same message will be on this guy. Removes it both sides. Removes the checksum value both sides. Which is a problem, right? Now we want to make sure that we change this behavior of the firewall. We want to tell the firewall, if you see options 19, what to do with it? Let him go. Do not do anything to the packet. The packet is fine. I have configured it that way. How do you do that? We do it in something known as, not here, TCP map. TCP map. Call it anything. I want to call this OP19, option 19. Right? You have certain options here, a lot of things you can match inside the TCP header. Which one do you think we want to match from here?
Checksum verification.
TCP options. TCP options. I'll say range. Now see, here you don't have an equal to option, otherwise I would say equal to. There is no equal to option. You have to specify everything in as per range. So I'll say range 19 to 19. 19 to 19, and then the action. What action do I want to allow? I want to allow which option? Option 19. I've just created it. I have not applied it, just like access lists. I've created the map, I've not applied it. How do I apply it? Class map. CM, comma, CM dash TCP. All TCP traffic. Match any. Any. I think you can match. Yeah, you can match it like that. I want to match all traffic. So match any. All traffic. Whatever traffic is going through the firewall. I want to apply which policy? I want to go inside my global policy. Global policy. And I'll call which class? Class CM. What did I call it? TCP. Right? The class is set. I want to set. Now see, here usually I would say inspect. This is what I used to do until now. Inspect HTTP, inspect FTP, inspect this, inspect that. Now I can also use this value called set. Set connection. I have some values, but the one which I will use is advanced options. What does it say? These are all TCP advanced options. He's asking me for the map name. The TCP map name. OP19. Right? What did I do? I'll do this again on the notepad. I said, see, there's two things. There's a TCP map, and then inside your class map there's set connection parameters. Inside where? Policy map, anything. Here we'll have it under global policy. Then call the class. Set connection values. This TCP map is used for what? The question is that. This is used for all TCP parameters. If you want to change tomorrow anything with respect to TCP header, where do you do it? Inside the TCP map. But this TCP map will always be called where? Advanced options. Here you can call the TCP map. TCP map used for modifications inside the TCP header. Everything, any modification you want to make inside the TCP header is done where? Inside the TCP map. Then you have to apply it to some traffic, right? You apply it using the same policy map, class map, and then the way to apply it using set connection advanced options. For this connection, I want to set advanced options. Which advanced options? Based on the TCP map, which I have specified in the TCP map already. In the TCP map here I said match option 19 and allow. Right? In my case right now, how did I do it? I said TCP map, call it anything, OPN 919. Right? How do I specify the range?
TCP options.
Yes. TCP options, range 19, allow. Right? I have not applied this policy, I'll apply this. Service policy, global underscore policy. Have a look at R2. Give it some time. This will not come up, but do you see a message change? Until now it was no MD5 digest. Now it's MD5 digest, invalid MD5 digest error. What is the difference? Why do you get this? See, this is not, firewall is not just one device with just one thing. It has many more complications. This was one, but these are all security complications. Now I told him to keep the checksum. Now he's keeping the checksum. Keeping the checksum in here. Keeping the checksum and let him go out. There's also one more thing the firewall does. To prevent anti-replay attacks, there's one more thing that the firewall does. What is that one thing? Whatever TCP packets are going out, whenever they reach the firewall, they have a sequence number. Right? They have a sequence number. The problem with that sequence number is if anyone on the internet knows that sequence number, he can actually send a packet back, although he does not have a SYN or anything else. He'll send a packet back with an increased sequence number. So this guy will have to accept it. Right? Because he knows I sent 11, he's waiting for 12. So the guy will send 12 back. He's an intruder. He does not need a SYN packet anymore. Yeah, so he sends out 13, then he'll send out 14, 15, 16, 17. Based on the sequence number, he can attack. Right? To prevent that from happening, the firewall has a rule which is known as, we call it randomize the sequence. Randomize the sequence number. So every packet that is going out from the firewall, what does the firewall do? Take out the sequence number and randomize it. And when the packet comes back in again, he changes the randomized back to the original one and sends it back to R1. Does it make a change? Does it affect anything, any communication that is happening right now? Yes? Does it affect anything here? It does. What is a checksum? If you go back to your VPN days, what is a checksum? What does a checksum mean?
Calculate all the bits. Keep integrity.
Integrity. Keep integrity. I have a TCP header. This is my TCP header. It has certain fields, right? It has a source port. It has a destination port. It has an options field, right? And then it has certain other values like you have fragment. No, it doesn't have fragment. It doesn't have fragment. It has flags, which include your S, your SYN flag, your FIN flag, your acknowledgement flag, your reset flag. Those are all here. It has an urgent pointer. A lot of other things. Checksum. What does checksum mean? Checksum means what the password that you selected, what it does is it runs through all of it and creates a picture of it. So it takes a picture of the packet which is leaving R1. Forgot, there is also the most important part here is the sequence number, also inside the flag, right? So the checksum, what it does is uses the password, creates a picture of all the picture. He doesn't send it as a picture, he sends it as a checksum value of the picture and hides this checksum where? Which part? Options 19. In this option number 19, he hides it. I think you can see it if you have Wireshark. I do have Wireshark running. Coming from 11, I should see option. This is the option. See, until now I couldn't see this option, remember? Now I have the option 19. The password and everything, the checksum is in here, in options 19. It's leaving R1, right? So this options 19 has the information of this checksum. It's a photograph of the whole thing. Now when R1 reaches the PIX, it reaches as this, right? Now he took the photo, but from the photo what did he do? He calculated a checksum and stored the checksum in the options field. Now this packet goes out, reaches whom? The PIX. What does the PIX do? Remember I told you? He removes this sequence number, adds his own sequence number. Adds a new sequence number. Doesn't do anything to the checksum, he lets it go. Lets the checksum go. Because I told him to allow options 19. So that's fine, he only does his own normal default behavior. This packet will reach R2. Now have a look at this packet. Reaches R2. It has its flags. It has its urgent. It has its port numbers. And it has the options field. Plus it also has, but a different sequence number as it was before, right? This guy, R2 has its own password, Cisco 123, which is the same on both sides. So what this guy does, he takes another picture of this just now and calculates a checksum. Also calculates a checksum when he receives it. Right? Once he calculates that checksum, he goes where? He goes into the options 19, this options 19, and looks at the checksum that was there before and combines these two together and sees if the value is correct, if the value is the same. Will the value be the same? No. Why? Because when this checksum was created, the sequence number was different. Now when I find the new checksum, the sequence number is different. So these two values are not going to be the same. So in this case, what is R2 saying? The message that you get here, it says invalid checksum. Before this, there was no checksum because option 19 was removed. Now it is still there, but he says invalid. I cannot compare the two. Right? Do you understand? You get the difference. So how do I fix this? How do I fix this problem? Is there any questions here? Is this clear completely? How the checksum works? That's how checksum works every place. So anyone who tries to tamper the packet during its journey from R1 to R2 will know and he will not accept the packet. That's why there is no neighbor relationships happening right now. Okay? So to fix this, I'll have to tell the firewall not to randomize the sequence number. Not to randomize sequence number. But should I do this for all traffic? No. I will not do this for all traffic because it's a good security feature. So I'll do it for exactly traffic going from R1 to R2. Only for that traffic. Only for BGP traffic. We can do it only for BGP traffic. Right. Let's do that. We can do it for port 179 also. Let's try to do it that way. I'll go to this guy. I'll create a class map CM BGP. I'll say match. I have a lot of things to match. I'll match port number. Which port number? TCP 179. Any traffic which is going to TCP 179, any traffic going to it will be matched by this class map. Create a policy map. PM. Sorry, global policy. Call the class which one? CMBGP. I have many options here. I also have one option called set, which I told you connection, right? This is what we did earlier. What is this option? What does it say? Random sequence number. Enable or disable? Still again in the same field. Set connections. Advanced options. The other was set connection. Which one? But I will not do this here because this I am applying to all traffic. This I am applying to all traffic. This I'll apply to a separate traffic. So first I'll say class map CM BGP match port equal to TCP 179, then policy map global underscore policy class CM BGP set connection random parameters, disable the parameters. Okay. Now one more thing, when you do this in a lot of iOS's, what happens is your neighbor will come up but you'll still receive these messages. which is just a bug in the iOSs. If your neighbor is up and you're able to exchange your networks, means everything is okay. First, let's go to BGP 100. Let's advertise the network. 5.0. Will only have a zone. The neighbor is active. Give it some time, it's BGP. Actually, you should have some prefix received. I applied the policy correctly.
The service policy.
I think I have the service policy. Global लगाई है ना? They're not receiving anything yet. They're not forming neighbors. Probably because of the class. Here I'm matching all traffic, right? So probably only this is happening because I'm matching all. He's going through the first class map and going through. He's not going to the second. Right? So what I'll have to do to fix this is class map CM TCP BGP. I'll say match port equal to match port TCP equal to 179. I'll just use this for both because set connection advanced parameters will also have TCP 179, right? So I'll go inside my class policy map. I'll remove these two. And BGP. I'll do which one? Class this. Two things I did, right? Set connection, advanced options was OP19. Set connection, the other thing was random sequence number. Have to do it under the same. Otherwise, when one matches, it doesn't go to the second one. So it only does one thing for both. So now both are done under the same class map, which matches port number 179. Now give it time. So it went back to no IP, no digest because I removed the class map, right? So it went back to the default behavior. Now the neighbor is up, right? Show IP, BGP. Have both routes, so IP route. I have the BGP route now. Both things got fixed. First, option 19 should not be removed. Second, if it is not removed, the checksum should also not be changed, and it's only changed because of the random sequence number. So you have to make sure that the random sequence number is not changed. Okay, is this clear?
सर दोनों remove both the class map. तो first में match ही नहीं था इसलिए नहीं हो रहा.
हाँ. See why it was not working?
match ही नहीं की जगह पे हम लोग किए रहते हैं.
वो भी कर सकते हैं. Yeah. So we had to change this class map. It was matching any, right? See, earlier it was like this. I'll tell you why it was not going through. Earlier when I did it, it was this. right? So this was match any. So traffic was going checking against this. Since it was ticking here, it was never going here. क्योंकि सारा ट्रैफिक कहाँ मैच हो रहा था?
TCP.
It was all getting matched with this TCP. So it was not going here. So it was doing the advanced options thing, but it was never doing the random sequence number. So what I did was I removed both of them. I created one class map in which I applied both policies. I said do this as well as do this to the same traffic. First, disable the random sequence number, and at the same time the options 19 should be allowed to go. So do this to the connection. Is this clear? Any questions?
For those two, the match any can be used.
Where? You can do that, but the problem in that case will be everything. Every traffic which is going through your firewall will have random sequence number disabled, so you will be open to anti-replay attacks. I'm doing it only for port 179 for BGP traffic, right? Because the class says TCP BGP. So in this class I'm only matching what? Port BGP. So only for the traffic which is going to BGP, my options 19 is not going to be removed. For every other traffic it will be, yeah?
So the first year written match any, it was matching every
This one,
port.
everything, yeah.
Every port.
Every port. Every port, yeah, every traffic.
Every traffic.
Every traffic. So I can remove this also. I don't need these. Right, so this is the refined version of it. This is the refined version, simple version of it. Okay, so what did I do for this? Was I did this right, but to do is as a separate one does not make any sense. So what I'll do is, where's my class CMTCP? I have not created TCP, right? Yeah, so this I'll move it up here. CMTCP BGP match 179, which is good. CMTCP BGP, set advanced options. Also set the connection parameters. Right, the refined version of it is this. To allow BGP to form why this is important, why this topic is important, because this gives you an insight of how to use the TCP map. How to use the TCP map and how to use this set connection advanced options. In real life, obviously you won't just have to face BGP, you'll have to face a lot more. But you should know how to use this part also. The process, how to use this part. Okay? Clear? Say this.